Now we're going to look at exercise 217, and it's all about adding, subtracting, multiplying and dividing algebraic fractions. So remember, when you add and subtract fractions, you need to get a common denominator, and that's what we're going to be looking at first. So let's look at our first few examples here. So for our first one, we're going to look at it and we're going to look and notice that we've got a 3 and a 4 on the bottom of the fraction. So what we actually want is to multiply this one, top and bottom, by 4, because that will give me my 12 on the bottom. And this one, top and bottom, by 3, because that will give me 12 on the bottom. Then I'll end up with a common denominator of 12. On the top, 4 lots of A, 4A. 2a times 3, 6a, and it's plus sign there. We add our like terms together. 4a and 6a make 10a. And now we also can notice that 10 over 12 cancels to 5 over 6, so it can become 5a over 6. Go to our second example, part B. We need to get a common denominator of 10. So I'm going to multiply top and bottom of the first fraction by 2. 2 lots of 11 give me 22m. Oops, missed my, there you go. Minus, now I've got to multiply the second fraction by 5 to get a 10 on the bottom. So 5 lots of 3 is 15m. 22 take away 15 is 7. So I get 7m over 10 as my answer to that question there. Let's continue. They're going to get a little bit messier now. I still want to get a common denominator of, for this question here, part C, 6 5s are 30. I want a common denominator of 30. It's the smallest number 6 and 5 goes into. So I'm going to get over 30. But I'm going to have to multiply the first fraction by 6 and the second fraction by 5. Multiply that out and we get 6m plus 18 plus 5m plus 5n all over 30. Do I have any like terms? Yes, the m parts, the 6m and the 5m can add to give 11m. Now you write the next bits, the order's not that critical. Now if I look at all 4 parts, is there a number that goes into 11, 18, 5 and 30? Only one, so that can't cancel. There's my final answer. Let's go to part D. Now, I've got denominators that are messy, so I'm actually going to put brackets in there. And what I'm going to do is the second fraction, I'm going to times the top and the bottom by k plus 1. And for the first fraction, I'm going to multiply the top and the bottom by k take 2, which means both fractions now have the same 2 brackets on the bottom. They have a k take 2 and they have a k plus 1. On the top, I've got 1 being multiplied to the k take 2, so let's multiply that out. 1 times k is k, 1 times minus 2 is minus 2. This bit's a tricky part. Let me actually highlight this next bit. That's a minus 4 being multiplied to k and a minus 4 being multiplied to a positive 1. So when I do that, minus 4 times k is minus 4k. Minus 4 times positive 1 is negative 4. Now we tidy up our numerator. The denominator is exactly the same. You never times the bottom of the fractions out when there's brackets. Makes it way messier than it needs to. On the top, I have a k, take 4k, which gives me minus 3k. And I have a negative 2, take away 4, which gives me negative 6. Could take a common factor out on the top, but I'm going to leave it like that. That's fine. Let's continue. This one, really messy, but what you need to be able to recognize is that the denominator here can be factorized. So let's factorize it. What two numbers times to give 4 and add to give 4? That'd be 2 and 2. So this question actually becomes 1 over a plus 2, a plus 2, plus 1 over a plus 2, and I'm going to put brackets around it. So this part here factorised to give me 1 on a plus 2, a plus 2. This part I didn't change. There's the plus sign between them. Now I notice the first fraction has a plus 2 happening twice on the denominator, so I'm going to put 2 of them on the denominator on the right side fraction. When I do that, I end up with a plus 2 happening on both fractions twice, so no longer going to write 2 of them, I'll just put a squared, and on the top I've got a 1 plus. Now I have 1 times a and 1 times 2, so that'll give me plus 1a plus 2, which will leave me with a plus 3, or you could have 3 plus a, it doesn't really matter, all over a plus 2 in brackets squared. Oh, another really messy one. These can take quite a bit of time because you've got to factorise bits individually. Now if I look at this fraction here, I can factorise that. It becomes 3 over a take 3, a plus 3, because it's a difference of 2 squares on the bottom. Difference of 2 squares, 3 3s are 9, there's that part. Then I have a minus sign. Now, I can factorise that part there. Let's just think about what two numbers. It's a quadratic, non-monic quadratic, so 2 and 3 are the outside numbers. 2 times 3 is 6. I need numbers at times to give 6 and add to give 7. They'd be 6 and 1. So just up here, I'm going to have 2a with 6 and 1. Where did the 2a come from? 2a, because we start with a 2a squared. Now 2 is going to divide into everything in the first bracket, which means my first bracket will become, there's a 4 here, but this part's now going to factorise down to a plus 3, because 2 goes into 2 once, and 2 goes into 6 3 times, so there's my 1a plus 3, followed by 2a plus 1. Now what you do notice is I have a common bracket on each fraction. I don't have a 2a plus 1 bracket on this side, so I'm going to times top and bottom by 2a plus 1. On this side over here, I don't have an a take 3 bracket, so I'm going to times top and bottom by a take 3. Now if I look at my fractions, I've got 3 brackets, I've got 3 brackets, all 3 brackets are the same, so I have a common denominator. It doesn't matter what order you put the 3 brackets in, as long as they're there. There are my 3 brackets. What I need to do now is expand the top. I've got a 3 being multiplied to 2a plus 1. So 3 times 2a gives 6a. 3 times 1 gives 3. This next bit, be really careful, because it's negative 4 times a and negative 4 times negative 3. Negative 4 times a gives negative 4a. Negative 4 times negative 3 gives positive 12. Now the 6a take the 4a gives 2a plus 15 all over my 3 brackets which don't change. And there's my answer. Let's continue. Now we've done adding and subtracting with our algebraic fractions. Now we're going to multiply. And remember, when you are multiplying, we need to make sure we factorise where we need to, and then we cancel before we multiply things out. That's the easiest way to do it. So cancel first if possible, and then multiply. Righto, let's have a look at the first one. It's not an algebraic one, but when you look at it, you could do it on the calculator, but you could look 7 goes into itself once, 7 goes into 14 twice. You could say 3 goes into itself once, 3 goes into 9 3 times. Let's multiply the top parts together and multiply the bottom parts together. 1 times 3 is 3 on the top, on the bottom 1 times 2 is 2, and there's your final answer. For part B, what you can notice is the top part here can be factorised. It's a difference of 2 squares, so let's factorise it. It becomes c minus 3 times 3 and c plus 3. Doesn't matter what order you put the plus and the minus in. And my second fraction, I'm going to put the c plus 3 in brackets. You can just add a bracket around that, that's fine. You can see that now when I'm cancelling, I've got identical brackets. They're going to go into each other once. I've also got 4 going into itself once and 4 going into 8 twice. That means I now end up with, on the top of the fraction, I've got a 2 and a c take 3. On the bottom of the fraction, if I times it out, I've got a 1 times a 1, just over 1. Let's times the top part out, 2c minus 6 all over 1, which you don't worry about writing the over 1. There's your answer. Now, mess, mess, mess. Let's see how we go with this one. The first fraction on the bottom has a common denominator of 4. So I'm going to take out my common denominator of 4. 4 goes into 12 3 times. There's my first part dealt with. The second fraction on the top, it's a difference of 2 squares. On the bottom, it has a common denominator. So the difference of 2 squares will become m plus 3 for this one, m minus 3, because 3 3s are 9. All over, on the bottom I'm taking out a common factor of 6, so I get 6 goes into 6 once, 6 goes into 24 4 times. On the top, I end up with, well, I'm finding 2 numbers at times to give minus 8 and add to give minus 2, because it's a quadratic simple quadratic trinomial. Numbers at times to give minus 8 and add to give minus 2 are minus 4 and plus 2. And on the bottom, it's a sum of perfect cubes. Now I know it's going to be m plus 3, because 3 cubed is 27, and then if I follow the formula, it's going to be the first part gets squared. M times 3 is 3m, and 3 times 3 is 9. So I've just used the formula there. Hopefully you can follow that one. If not, get your sum of perfect cubes formula out and follow it. Whoop, I have made a little mistake there. That should be a minus, not a plus. Need to be careful there. Now, let's keep going and see what we can cancel now. So if I look for anything identical top and bottom, there's an M take 3, there's an M take 3, they go into each other once. There's an A take 4, there's an A take 4, they go into each other once. There's an M plus 3, there's an M plus 3, they go into each other once. There's a 6, 3 goes into 6 twice, 3 goes into itself over there once. What am I left with now on the top? I've got an A squared, and I've got an A plus 2. They're the only things that are left on the top. All the others went into each other once. On the bottom, I've got a 4 times a 2, and 4 times 2 gives 8. And then I've got my new bracket. Now, hopefully there's no silly errors in that one there, but that should be your answer. When you're dividing, you do the same thing that you do when you multiply, except the fraction after the divided by sign gets inverted or reciprocal, or the reciprocal is taken. Let's see what we can do with this one. That becomes 1 over x. We change the divide to a times, and then the 6 over x gets inverted, or we take its reciprocal, so it becomes x over 6. When I look at that, x goes into itself once and once. Multiply the top parts, you get 1. Multiply the bottom parts, you get 6, and there's your answer. Same concept. 2ab over 3 doesn't change. Need to change that divided by sign to a times, and then we flip the following fraction. When I look at that, okay. 2 goes into itself once, 2 goes into 6 3 times. Nothing else cancels. So you end up with, on the top, you've got an AB times an 8a, so you'll get 8a squared b. On the bottom you've got a 3 times 3, which is 9, and there's our final answer for that one. Part F, we have a 3 over 5 times a 10 over k, that's fine. But I'm going to change the divided by sign to a times, which means the 12 over k gets flipped to a k over 12. Then I'm looking for things that might cancel. The k's go into each other once. 5 goes into itself once, 5 goes into 10 twice. 3 goes into itself once, 3 goes into 12 4 times. Oh, I can actually look and see that there's a 2 there. 2 goes into itself once, 2 goes into 4 twice. What am I left with now on the top? On the top I've got a 1 times a 1 times a 1, which is 1. On the bottom I've got a 1 times a 1 times a 2, which is 2. There's the answer to part F. Let's now look at continuing on the exercise as fast as you can. Have fun.